Hello, welcome to another lesson of vectors. Today we're going to learn about vectors in space. Here's our little alien. Now, when we're drawing vectors in space, we're going to add a third dimension, which means we're adding another axis. Our x-axis is now going to be the axis that's coming out towards us. Our y-axis is the one horizontal, and z-axis is going up and down. Every year people get confused saying, why isn't this x, y, and then just throw a z on. I have no idea what the reasoning is behind it, but this is the way it is. Alright, so x is going this direction. One thing to notice that although this is 1, that's 1, x, one diagonal that way is not 1. It's going to be a lot smaller than that. That distance is much more than this distance here. So if you do about 2 for every 1 diagonal, that's enough where it would make sense. Alright, so that's how we make our axis. Now, there's also another way to graph. Oh, I should graph one point on here. Let's say I graph the point vector 3i plus 4j plus 2k. What that means is I go out 3 in the I direction, so I is still matched up with x. So first thing we do is make a dotted 0, 0, 0, go out 1, 2, 3, and we make a dot, or point. Now we go out 4 to the right, so we're going out 1, 2, 3, 4. Now from here, just imagine we're moving 1, 2, 3, 4. So we move 4 out to the right from both of those points. So let's draw these dotted lines like so. So this is going to be the base of what we're doing. Alright, so now we're going to move 2 up from each of these points. So from these ones it's pretty easy, just move 2 up, 2 up. Now from here we have to go 1, 2. Just realize if you start in the middle, you're going to have to end in the middle. And now if we draw the rest of these to connect it, you'll see we just created a box. Now we need a box in order to show depth, to show exactly where our vector is going. Our vector starts at 0, 0, 0, goes 3 in the x direction, 4 in the y direction, and then 2 up. So our vector looks like this. Without our box that is drawn here with dotted lines, we have no idea what this vector would represent. The box gives it shape, gives it depth, so we know exactly where that point is. Alright. Now there's another type of graph paper that makes it a little bit easier to graph, where it does the diagonal in units. So you can so in this one, let's do the same thing. We start at 0, 0, we go 2 out, we go 4 to the right, 1, 2, 3, 4, 4 to the right, and now we're going to go 5 up from each of those points. 1, 2, 3, 4, 5. 5 would be there. From here it would be 1, 2, 3, 4, 5. Now the tricky part in this one is finding this point. Let's do every other segment first, and then it will be should be somewhat obvious where that next point goes. right. So here is our box. Now it's going to come over, and it's going to go straight down from there. So that's how we can find our point. It's going to be directly to the right of that and directly up from this point. All right, now we have this nice box, gives it depth, and our vector of interest goes from 0, 0, 0, 2 towards us, 4 to the right, and 5 up. So that's the point that I'm going to. So this is 2i plus 4j plus 5k. Now if we want to find the magnitude of that, it's a little tricky. That's 2, that's 4, and that's 5. So before we can find that magnitude, first we have to find this magnitude. We'll have 2 squared plus 4 squared, and then we'll square root that. So I'll just call that the square root of 2 squared plus 4 squared. That's going to be this distance here. Now, that sets up a right triangle where I have this and this side. So this would be 2 squared plus 4 squared square root. And then that thing squared plus 5 squared will now be c squared. So if I square a square root, that would just get rid of that. So I have 2 squared plus 4 squared plus 5 squared. It's going to be c squared. Now notice that I'm just taking this side, or all 3 dimensions, 2, 4, and 5, squaring them, adding them together to equal t squared. So this is Pythagorean theorem for 3 dimensions. So if I want to find that actual length, this would be 4 plus 16 plus 25, which is 20 plus 25, which is 45. So the square root of 45, which has a 9 in it, which would be 3 root 5. So the magnitude of p is going to be 3 times the square root of 5. So if I want to find the unit vector, which it says down here, find the unit vector for p, I take each of the dimensions, 2 divided by 3 root 5, I, plus 4 divided by 3 root 5, j, plus 5 divided by 3 root 5, k. And that will be my unit vector. Now I could rationalize this. It would be 2 root 5 over 15, or 4 root 5 over 15, or 5 root 5 over 15, which would be 5 over 3. But this is good enough for right now. Alright. Now, you guys take a second, try to draw this out on a piece of graph paper, find its magnitude, and then find the unit vector for p. When you're done, press play. Alright, so we start at 0, 0, 0. We go 3 down, 7 to the right, 1, 2, 3, 4, 5, 6, 7. 7 to the right would be right here. And then we move 4 up from each of those points. 4, 4, 1, 2, 3, 4, and then right there. So if I draw my box, it'll look like this. And some people, after doing this a couple times, will say, do I really need to draw the box? And that answer is always yes. Without the box, we don't know where the vector actually lies. You need to give it depth. So we start at 0, 0, 0. We went 3 out, 7 to the right, and 4 up. So this is my vector p. To find the magnitude of p, I would take 3 squared plus 7 squared plus 4 squared. And this would be 9 plus 49 plus 16. This is 58 plus 16, which is 74. So This would be the square root of 74. 74, I don't think that divides into anything. No, it doesn't. So this is going to be the square root of 74 as a magnitude. So to find the unit vector, that would be 3 over root 74i plus 7 over root 74j plus 4 over root 74k. Hopefully you did that correctly. Alright, now operations of 3D vectors are just the same as those in 2D vectors. So if I wanted to add a plus b, 4i minus 2i is 2i. This would be plus 2j. Say j, write k. Alright, take 2. 2j. 3k minus k, that would be 2k. A minus b, 4 minus negative 2, 6i. Negative 6 minus 8, negative 14k. J again. 3 minus negative 1, that would be 4k. Now if I want to find the magnitude of a minus b, I just look at a minus b, and this would be 6 squared plus 14 squared plus 4 squared, and then square root that. So remember Pythagorean theorem for 3 dimensions. So that would be 248. So the square root of 248. Something's got to go into 248. Just a 4. So that would be root 4, root 62, which would be 2 root 62. Now negative 3a, I would just take negative 3 and multiply it by each of those a values. So that would be negative 12i plus 18j minus 9k. That's what negative 3a would be. Multiplying 3 by each of those values. Now to find the displacement vector from point A to point B, that's the vector AB. Remember we take vector B, subtract it from vector A. So that would be 5 minus 3, which would be 2i, 1 minus 7, minus 6j, 9 minus 4, which is 5k. Now, once we have that, if I want to use that to find the distance between point A and point B, I can, the distance from A to B is going to be 2 squared plus 6 squared plus 5 squared, and then square root that. So 2 squared plus 6 squared plus 5 squared be 65. Now, so the square root of 65 I don't think can be taken. So the square root of 65 is just the square root of 65. And if you want to know the exact decimal, or an approximate decimal, square root of 64 is 8, so this has got to be just a little bit above 8. Alright, now if I want to find a vector that goes from point A to 60% of the way along the displacement vector AB, I'm just going to do 60% of AB. AB we have, so 0.6 times 2 is 1.2i, 0.6 times 6 is negative 3.6j, 0.6 times 5 is 3k. Find a position vector to the point 60% of the way from A to B. So now we're doing position vectors. Now we have to remember how this worked before. We always went from 0, 0 to our first point and then 60% of the way. So what we want to do is add A plus 60% from A to B. Alright. I don't remember what this was. A is 3i plus 7j plus 4k. 60% of AB is 1.2i minus 3.6j plus 3k. And now we add the i's, 4.2i, add the j's, so that would be 3.4j, and add the k's to get 7k. Now the position vector is great because it can show us the coordinates of the point really easily. It would just be 4.2, comma 3.4, comma 7. Alright. Now if we want to find the displacement vector from F to G, that's the vector FG. We take G, where it ends up, minus where it starts. So that would be 7 minus 3, which would be 4i. 9 minus 5, which would be plus 4j. 4 minus 1 would be 3k. If we want to find the position vector, that's 3/4 of the way from F to G. First we go to F, then we go 3/4 of the way from F to G. So F is 3i plus 5j plus 1k. 3/4 of the way to FG would be 3/4 of 4 is 3, so 3i. 3/4 of 4 again is 3. 3/4 of 3 is 9/4. Okay. So when we add these up, this would be 6i plus 8j plus, this is 2 1/4, so 3 1/4, so 3.25k. So that's the position vector 3/4 of the way from F to G. Last one. Let's find the displacement vector QP. QP. Now hopefully everyone pauses this and does it by themselves first. This we take P minus Q, which would be -2 minus 7, which is -9i. 1 minus 3, which is -2j. 5 minus 3, or 8, which is -3k. So this would be the position vector Q to P. Now if I want to find the distance from Q to P, the distance is going to be this magnitude. So the magnitude from Q to P is going to be 9 squared plus 2 squared plus 3 squared. And then square root that. So this is going to be 81 plus 4 plus 9, which is 94. So the square root of 94, which I'm pretty sure nothing goes into, so that's going to be the distance. If I square rooted 94, that would be a little bit less than 10, because square root of 100 is 10. So it would be 9.7-ish. Alright, here's your homework. Chapter 3. Hope that lesson was good enough to get you through it.